Polaroids P1 and P2 are placed with their axes perpendicular to each other. Whereas the unpolarized light, which is having an intensity of I naught, is incident on a P1. The third polarizer P3 is kept in between P1 and P2, and it is making an angle of 45 degrees as well. And the question here is, what is the value of intensity of a transmitted light through the Polaroid P2? So first, we have to calculate the intensity of a polarized light when it is coming from Polaroid 1. So unpolarized light is incident on a Polaroid 1 is having an intensity of I naught. After it passing through P1, the light becomes polarized and half the intensity will be transmitted. So we can write the I1, which is nothing but the light is coming out of P1, will have an intensity of I naught over 2. Again, it will enter into the Polaroid 3. So the axis of Polaroid 3 is 45 degrees with respect to P1. So here we can use a Mallows law, which is nothing but I is equal I naught cos squared theta. So here we are calculating the intensity of I2. So I2 will be equal to the intensity from the first Polaroid. So I1 times cos squared 45 degrees. So here we have a value of I1, which is I naught over 2, whereas cos square 45 degrees will be equal to 1 over 2, right? So when we are simplifying this, we will get the value of I2, the light from the polarizer 3 will have an intensity of I naught divided by 4. So again, this will enter into the Polaroid 2. So here, again, we can use a Mallows law. So I3 will be equal to I2 times cos squared 45 degrees. So here we have a value of I2, which is I naught divided by 4. We know that the cos squared 45 degrees will be 1 over 2. So when we are simplifying, the intensity of the light which is coming out of polarizer 2 will be I naught over A. So the correct answer for this question is option B here.